After we learn about anion analysis, we continue with cation analysis. First of all, we discuss about flame test. The flame test will result or yield color of flame when we burn the substance directly on fire. First, we have lithium Li plus, this one, crimson, sodium Na plus, yellow, potassium K plus, lilac, rubidium Rb plus, gray to purple, cesium Cs plus, violet, calcium Ca2 plus, brick red or orange to red, strontium Sr2 plus, bright red, barium Ba2 plus, apple green, copper CO2 plus, blue green. For the identification of cation, we use solution of NaOH and ammonia NH4OH. We add NaOH first. If precipitate form, then check the color. If the precipitate is colored, then we should observe further. What is the color? If the color is light blue, what we have is Cu2 plus ion. When the color is brown, what we have is Fe3 plus ion. When the color is green, what we have is Fe2 plus ion. Or for Cr3 plus, also green. To differentiate which cation we have, then we follow by adding excess sodium hydroxide, NaOH. If the green precipitate dissolve in excess NaOH, what we have is Cr3 plus. When the precipitate does not dissolve, then what we have is Fe2 plus ion. When the precipitate has no color, then we still add excess NaOH. If the precipitate dissolve, then what we have is an amphoteric. That is Al3 plus or Zn2 plus. Then, to differentiate between Al3 plus and Zn2 plus ion, we repeat the experiment by adding ammonia solution. The zinc will dissolve, the Al3 plus ion will not dissolve. If the colorless precipitate or white, white precipitate, not colorless, white precipitate, when we add with excess NaOH and then the precipitate does not dissolve in NaOH excess, what we have is Ca2 plus or Mg2 plus. To differentiate between Ca2 plus and Mg2 plus ion, then we do the flame test. The color of Ca2 plus is brick red, but the color of Mg2 plus is like bleach color. Ammonium NH4 plus is a cation that does not come from a metal. Here non-metal, non-metal. We can identify the presence of NH4 plus ion by adding NaOH. Of course, we cannot identify by using NH3. There is no reaction. So we use NaOH, aqueous. When NH4 plus ion presence, then we add NaOH. For example, the NH4 plus in the form of in the salt of NH4Cl. Then there is a reaction to form NH4OH plus NaCl, and the NH4OH decomposes into NH3 gas and H2O liquid. Then the production of NH3 gas from the reaction we test by using damp red litmus paper that will turn blue. For coupled 2 ion or Cu2 plus, when we add with NaOH, the precipitate form is this one, blue, and will not dissolve in excess NaOH because Cu2 plus is not an amphoteric. When adding with ammonium hydroxide, the precipitate the same because what we add is OH minus. But in excess ammonium hydroxide, if we add more to the precipitate, then the precipitate will dissolve this one in deep blue color to form solution. For iron 2 ion Fe2 plus, this is the green color of the precipitate. The green color precipitate will not dissolve in excess NaOH because Fe2 plus ion is not an amphoteric. Also, in excess NH4OH, the FeOH2 precipitate, this is green PPT, both with NaOH excess and NH4OH excess, the precipitate will not dissolve. For iron 3 ion or Fe3 plus, the color is brown, insoluble in excess, and insoluble in excess NH4OH. When we have ion Fe3 plus, we add either with NaOH or with NH4OH, the same. In this case, what we add is OH minus. Then Fe3 plus and OH minus will form FeOH3 precipitate that not dissolve in excess NaOH nor in excess NH4OH or ammonium hydroxide. For this figure, the green one is Fe2 plus, the orange is Fe3 plus. When we have Fe2 plus, I mean the green here is not Fe2 plus but FeOH2. After some time, we put exposed to the air, then the FeOH2 will be oxidized into FeOH3. So the color changes from green to orange or brown. Chromium 3 ion or Cr3 plus ion, when we add with NaOH, will form green precipitate that dissolve in excess NaOH. Because Cr3 plus is an amphoteric, then will react with NaOH. The CrOH3 will react with NaOH. That makes the PPT of CrOH3 dissolve. But when we add ammonium hydroxide, the gray-green precipitate of chromium 3 hydroxide or CrOH3 solid will not dissolve in excess ammonium hydroxide, so still remain as gray-green precipitate. For calcium Ca2 plus with NaOH will form white precipitate of CaOH2 that insoluble in excess because Ca2 plus is not an amphoteric. When we add with ammonium hydroxide and H4OH, then there is no precipitate, only a very slight PPT like this. Why? Because ammonium hydroxide is a weak base which decomposes into slightly NH4 plus and OH minus ion. So the OH minus ion from ammonium hydroxide is not enough to form CaOH2 solid. For magnesium ion or Mg2 plus ion, when we add with sodium hydroxide, white PPT of MgOH2 is formed. that is insoluble in excess. When we add ammonium hydroxide, white PPT of MgOH2 still formed and insoluble in excess. The solubility of group 2 going down the group, the solubility of hydroxide is getting better. So, CaOH2 is more soluble in water than MgOH2. So, for Mg2+, there is no problem when we add ammonium hydroxide. Still, white PPT of MgOH2 form. Zinc. Zinc ion Zn2+, when we add with NaOH, will react to form ZnOH2 precipitate white PPT. When we add more NaOH until in excess, then the precipitate ZnOH2 will react with NaOH to form colorless solution Na2 ZnO2 or sodium zincate. And water. When we add with ammonium hydroxide, white PPT form and also soluble in excess because ZnOH2 with ammonium hydroxide will form a complex. For aluminum, this is an amphoteric. When we add NaOH, the white PPT of AlOH3 will dissolve in excess, while when we add ammonium hydroxide, the white PPT does not dissolve in excess. The reaction between precipitate AlOH3, solid precipitate, and NaOH will form sodium aluminate, that is solution or aqueous, NaAlO2. Amphoteric meaning that the substance react both with base and with acid. So for AlOH3, when we add NaOH, will form salt, sodium tetrahydroxoaluminate 3, and when we add with HCl, will form aluminum chloride AlCl3 plus water.